Are you able to hear me?
Yes, sir.
And also you see the file, right?
Yes,
Okay,
sir.
okay, good. So you see this much pressure working in the right side, multiply the area, you get force. This is positive because working toward right. And on the right hand side, pressure is this much and this is the area. So this is my total force is negative because working toward left side. Now you multiply by dx, dz, just simplify. So I'll mention I forgot over here. What will be dy into dx into dz. Similarly, right over here will be dx, dz. And you see this p will be out. And this one, dx, dy, dz is a volume. Even it is small, you cannot ignore the volume. So volume is very small, but it has a value. That means delta V, right over delta V. So what is over here? Half minus half x minus half x. So you will get a, and then my negative sign the left side, right hand side is 0. So you can write down this one, right? And from how the two term is over here, product is 0, is delta V times this one, but we don't know which one is 0. Is delta V 0? Is possible? Volume cannot be 0, right? So obviously delta P by delta Y is equal to 0. So delta P by delta P equal to 0. What does it mean? What is it? Like if I say dr divided by dt, what does it mean? It meaning that the rate of change of r, or r is not, if this is 0, what I will say? That value of r is not changing with time. So similarly, right over here, we can say the pressure is not changing along y direction. So say fluid pressure does not change along y direction from here. How we can figure out? Right over here, I can say dr equal to 0. You do the integration both sides, then what will get? R equal to constant, right? You will get value R equal to some constant, say you got C1. Constant mean value is not changing. Now, similarly, we will say along x-axis. That means the pressure is working like right over here and right over here. Okay, that will check it. So similarly, along x direction, fx equal to 0. Let me bring that figure at the bottom. Okay, so we are taking along x direction. So along x direction, pressure this side is working in negative x direction, right? So pressure is P plus delta Px plus dx by 2. Similarly, we use the Taylor series. This is the pressure. And
Sir,
yes,
sorry sir, disturb করলাম স্যার।
uh,
স্যার দুই একজন মেবি স্যার ওয়েটিং রুমে আছে স্যার।
still some people waiting. Okay, let's
জি
see.
স্যার।
It's supposed to give me the pop up the window. Okay, I allow them. Okay. So this pressure working along negative x direction, and one more pressure along this surface working along positive x direction. So Siam, your mic need to be mute. Okay. So you see right over here, this is my pressure, this is area. Similarly, this is pressure and this is the volume. I put dy, what is that, this area? dy into dz, right? So why I put this on Thomas? I put twice. Okay. Now this p term will be out. You have similarly this term. So you can say half delta p by delta x into del v equal to 0. And similarly, you can say from there that del p by del x equal to 0. What does it mean? No pressure is changing along x direction. That means along x and y direction, pressure is same. So what is x and y direction? You see, x and y direction mean horizontal direction, right? You see right over here. Your x and y is the same plane. That means horizontally pressure is not changing, not along x-axis. X-axis this way, not along x-axis, not along y-axis. Now, need to say about the vertical axis, that what will be happen. So vertical axis, how many force working? You see in vertical, this surface, there is a pressure working downward. In the bottom, there is a pressure working upward. And what else we have? Other thing, the weight of this fluid. So how can figure out the weight of the fluid? So you see pressure right over here along positive Z, right? So your H will be dz by 2, and this is positive. And this force right over here working negative Z direction. So this is the pressure. This is the pressure we found by Taylor series. And what will be this area? dy into dx, right? So this is the pressure. This is the, I'm sorry, area. Similarly, at the bottom, right over here, pressure is P. What will be pressure at this surface? In that case, my H will be minus dz by 2. So this will be pressure. And this pressure working upward. So you get dx into dy. Now, the weight of the object is working downward. So how will get the weight? So weight W, if I say right over, weight W will be equal to E multiply by rho, then multiply by G, then multiply by volume. Now G rho, this is G and rho, is called gamma, specific weight of the fluid. So instead of 0, I can put the gamma times volume. This is the weight. So weight of this fluid element working downward, the negative Z direction. So this is gamma, this is volume, dx, dy, dz. Now you just multiply all the side. If you multiply all the side, then P will be out. So it will be this one in the right over here, this value right over here, it will be this value right over here. So our dx, dy, dz equal to delta volume, del V. Right over here, del V, right over here will be gamma into del V. So now what you see, these two term, this is half x, this is half x, right? This is my x, these two term. So you'll get the one full term right over here. So you are getting one full term, then minus del V. Now you see del V volume cannot be 0. So you are getting this one. Del P by del Z equal to minus gamma or minus rho Z. So what do you see? That means fluid pressure along Z direction, the one vertically is changing, is no more constant. Now, this one we can say What is the difference between del and d? Anyone? Say, I am writing over here, del p.
ডেল্টা হচ্ছে
Yeah, go ahead. When you'll use this one.
স্যার ডেল হচ্ছে আমি স্যার এটা তখনই করব যখন আমি শুধুমাত্র এক্স এর উপরে ডিফারেন্সিয়েটটা করব সেটার ক্ষেত্রে মানে একটা
Okay,
পার্টিকুলার
good,
ক্ষেত্রে, আর
good.
ডিটা
Yeah.
হচ্ছে আমার ওয়াই এর উপরেও আমি করতে পারবো।
If you have multiple variable, then you'll get the partial derivative. Then you have single variable, then you got the derivative. Okay. So right over here, there's no more variable in the right hand side. That's why instead of del p by del z, then we can say derivative del p by del z. Okay. So del p equal to rho g z. Right now, this one will integrate both sides between 2 points. Let's see how we can integrate between 2 points. I am taking 2 point 1 and 2 right over here, and from the top surface height of point 1 is h, and from the bottom surface this point 1 is z1, and depth from the bottom surface, or you can say from y-axis, its distance is z2, and for point 1 distance from y-axis is z1. So what does it mean? If I think this is the top surface of the water or sea, then what will be the pressure at point 1? That means at a depth h. That we will figure out by integration. So if you integrate between right over here in the both side from point 1 to 2, then you'll get this one. Pu2 minus P1 equal to rho g Z2 minus Z1. Now Z2 minus Z1 equal to what? Equal to H. So right, this side you got the H. Now P2, pressure at the top. That means no pressure. That means atmospheric pressure, right? So we put our atmospheric pressure minus P1. That pressure we need to figure out. So we say P1 equal to rho gh P atmosphere. So right over here, you will get absolute pressure. You will get absolute pressure. Why absolute pressure? Because you add atmospheric pressure with this value. So this will be absolute pressure. So what is actually the okay? That means if you put a pressure gauge at the bottom of a sea or river, right over here, you put a pressure gauge. What reading he will show? He will show the reading P1 equal to rho g, this value. So this pressure is given by a meter, by a gauge. That's why it is called gauge pressure. So with gauge pressure, when you add atmospheric pressure, then it become absolute pressure. Okay. So what you see, pressure of a object in a underwater or under fluid, it depends on depth. If depth increase, pressure increase. If depth decrease, pressure decrease. Okay. Any question? Any question from anyone? Or do you have any confusion? Hello? No? I'm not getting. Adib Noor, your mic is open. So do you have any question?
No, sir.
No? Okay. So we can stop it, right? We can stop it over here and see you on your section A. So next Monday. Okay.
Yes, sir.
Okay. Thank you very much.